Okay, section 6.2, properties of parallelograms. We're going to use relationships among sides and angles of parallelograms and also relationships among diagonals of parallelograms. So we're going to look at all the properties, all the definitions, and kind of see what they have to go with it. So first of all, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So in the word, it says parallel in it. It means both opposite sides are parallel. Remember that the filled in triangles mean that they're parallel. They're not the same, okay, necessarily. They usually are, but not always. So the ones with double triangles that are filled in, and usually they're red in the book, but on a quiz you would just see that there's either a single or double filled in triangle because they would be black and white. So look for opposite sides parallel. If they do that, that's just using the definition. The first one, again, said if a quad is a parallelogram, opposite sides are congruent. So here is where we do know that if they tell you it's a parallelogram, you do know that opposite sides are the same. So if they give you, for instance, a 2x plus 7 on the top and an 8 on the bottom, you can set them equal and you can solve for the missing part. So we'll be doing that in a little bit. Here's a little proof. Parallelogram ABCD is what we have. We want to prove that AB is congruent to CD and BC is congruent to DA. So let's look at this one. I'm going to fit it all on one page here. So I have some things in here and I have some things that are missing. So first of all, we have ABCD as a parallelogram and that is given. So when we're looking at it, it looks like I skipped a couple things here. Let me fix it. Don't do parallel here. It should be AB congruent to CD. And put a congruent symbol there. And actually, I do want to leave that parallel in there. But there should be a AB and CD. Okay, and this is definition. Parallelogram. Okay, I usually draw the shape. You can certainly write the word, but make sure, and I don't know why it's not writing on there. Let me try it again. There we go. Okay. So definition said that opposite sides are parallel. Now, anytime you have things that are parallel, we have to think of all the angles that we studied before. Alternate interior, alternate exterior, same side interior, corresponding, vertical, all of those things. So when we're looking at this one, we now have parallel lines cut by a transversal, and that's kind of what you want to think about. So generally, you're going to use just the interior things that we learned. Most of the time, it's either vertical or alternate interior. For parallelograms, you're going to be probably shooting for that alternate interior or sometimes same side interior, depending on which one it is. So alternate interior angles, we're going to do two sets of these. Angle 1 is congruent to angle 4. So you're looking at the ones on the different sides and opposite ends. And we're going to go angle 2 congruent to angle 3. So I'm going to double hash mark those. Anytime we see reflexive, we are probably going to use something that is the same in both of them. So I'm looking at the segment AC is the same as itself. So I'm going to mark this one. So how are those triangles congruent? We just kind of got done studying those. What do we have marked in a single triangle? Side, 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 angle, side, angle, side, angle, all of those. Angle, side, angle, so we're going to put that in there. So that actually is the same. The only thing right now that's new that you are looking at is the definition of parallelogram. That's the only thing that's new. And then once the triangles are congruent, that should be angle, side, angle, but the A didn't come up. Just a second. There we go. Once we have everything congruent, we can say anything we want to about the rest of it. So then they say A, B, and C, D are the same, and B, C, and D, A are the same. Corresponding parts of congruent triangles are congruent. So that proof should look kind of familiar. The only thing new was the very first step. So not a super big deal. The rest of the lesson today, we're just going to be using those properties and stuff that we wrote down. So this part, I think usually students have a pretty good idea of what we're doing. If you have to explain, you're just going to put the theorem number on there and go from there. So consecutive angles are angles that share a side. And if you didn't do the vocab yet, you'll do that here in a little while. Next theorem, if a quad is a parallelogram, then its consecutive angles are supplementary. So here, when I'm looking at consecutive angles, B and C are consecutive. They share a side. C and D are consecutive. D and A are consecutive. So when you're looking at it, it's the ones in order. So A and D, you can't skip across. You have to go next to it. So the consecutive angles to A would be D and B. Those are all consecutive, but not at the same time. So A and D are consecutive, and BA are consecutive separately. This one, what is angle P, the measure of angle P? So again, it said consecutive angles are those that share a common side. It also said consecutive angles are supplementary, so you got to remember that. So in this one, we want angle P, and they give us angle S. Are those consecutive? They're kind of in order around, right? So P plus 64 equals 180, because that's what supplementary means. So the measure of angle P is 180 minus 64, whatever that is, 116. If you're doing supplementary, set up the equation, please, and then give me the answer, just so that I know you're using the theorem. Suppose angle S is 86. What's the measure of angle R? Sorry. So S is 86 this time, so I'm going to cross it out. So we'll go S is 86. They want to know what R is. So when we're looking at them, we're looking at S and R at the same time. Those are also consecutive. So R plus 86 equals 180. And when you subtract 86, you get R is 94. So it's all about that theorem that we just looked at. So consecutives are supplementary. Consecutives are those angles that are one after the other. Then they go into these two theorems with properties. If it's a parallelogram first, then opposite angles are the same. And when you look at it, it kind of looks that way. So here we've got two acute angles. Those are going to be the same. We also have two obtuse angles. Those are going to be the same. So opposite angles are the same. Also, diagonals bisect each other. That means just cut in half. So this diagonal right here cuts this one in half. This one cuts that one in half. And they have those two little parts marked. So the two parts on either side of that diagonal are the parts that are the same. Okay, now they're going to give you pictures with sometimes angles, sometimes diagonals, and all that good stuff. It says solve a system of linear equations to find x and y. This one obviously is a parallelogram. So you're going to set this part right here equal to this one, and this part equal to this part. The part that is hard about this one is that they have x's and y's at the same time. So this is something that you probably did back in Algebra 1. X equals y plus 2, and y plus 10 equals 2x minus 8. So you kind of have to solve them together since they have two variables at a time. It's set up for substitution. So when you look at it, here's what x is. You're going to plug it in for this variable right here. So it's substitution. And here's what it'll look like. Y plus 10 equals 2 times y plus 2 minus 8. Now, when you substitute that in, you should have the same letters left. If you still have opposite letters, you plugged it in for the wrong thing. So it should make it look easier once you do this. So we'll do distributive property on the right. So 2y plus 4 minus 8. And then we'll get the y's on the same side and the numbers on the other. So this side gives you a negative 4, and we'll subtract 10 from it. Negative 4 minus 10, 14. So y must be 14. Now, we have to solve for x as well, so we're going to substitute it back in. and this is where you plug it back into that original one that we used. So x is going to be 14 plus 2, which is 16. So 16 and 14. Sometimes they do them so that you don't have to use x's and y's at the same time. So sometimes they'll go y plus 10 here and 12 there, you know, and 15 and x plus 2. So sometimes they're a lot easier than this one. I just did this one. Yep.
Where do you get positive 14 if it's an x?
I divided by -1. There's a negative on each side. I just didn't say that. Yep. Also, you can show the steps here too. I just didn't. So if you are wondering, I put these together and then I subtracted 10. That's where I got the -14 from. I also subtracted 2y from both sides. Some of you might bring the y to where it's positive, and that's totally fine as well. One thing that I haven't done yet is answer the question. It says, what are Km and Ln? So they want this whole entire thing. So we need to plug it in for both those things. So Km, I'll put it up here, is 14 plus 10. So I plugged it in for this part. I'm also going to plug it in for that part. Plus 2 times 16 minus 8. Because the whole entire thing would just be those added together. So we have 24 plus 32 minus 8. And that is 48 is correct. Now, there's one other thing that you could do there. Since it bisects, you could plug it in for one of them and double it, which also makes sense. Okay, now the other one, we're going to plug it in as well. Ln, I'll put that one here, is x plus y plus 2. So I'm going this way this time. X is 16. And then we have plus 14 plus 2. So 16 plus 14 plus 2 is 32. So that's the answers that they want at the end. The diagonals bisect each other. They are not the same. If you look at them, there'll be one that definitely looks longer than the other. The one that goes to the acute angles will be longer than the one that goes to the obtuse angles. So sometimes you're looking for diagonals. On this one, I'm just going to set it up. It's going to look kind of like the other one. Again, they're using alternate letters. They don't always do that. So for this one, they would do y equals x plus 1 and 2x equals 3y minus 7. We would plug this in for y this time. So it looks very similar, and then you'd have to substitute them in at the end. Theorem 6-7, this is the last part. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. They could have 8 of these. It doesn't matter. If the first ones are parallel, the last ones are going to be parallel as well. Remember that these symbols right here indicate parallel. They're not the same. And what you're looking at is segments that are congruent. So if you have these two segments on this side are the same, that makes these two on this side the same as well. So the ones on the right are the same, the ones on the left are the same in that one. Okay, so here's kind of an example of this one. It says A, B, B, C, C, D are 2. That means they're all the same. Okay, so this one's the same as this one's the same as that one. If we know that, and we know that all the lines are parallel, which they are, it says EF, this one, is 2.25. What do you know about this one and this one? They're all 2.25. So is there going to be a lot of work? Probably not. We want EH only. We want the length of it. So EF equals FG equals GH, and they're all 2.25. And if they want the entire thing, we just take it times 3. How much was it? 6.75. Okay. So again, just make sure you're answering the question at the end of that one. Okay, and then there's one more got it question. It evidently is using the same picture. Okay, so EF F, G, GH are all 6. Again, that makes those all the same. AD is 15, so the whole thing is 15. Would these all be equal? They would. If the other side are equal, that would be equal. So we're going to take 15 and divide it by 3. And all of those are 5. So you can go either way. You can have the whole entire thing, divide it in 3 or 4 or whatever it happens to be, or you can find the individual parts as well. And that is all I have.